So same function, if I go over 2 units, I should go up 2 to the 6, which is how much? 64, but I only go up half of that, so that's 32. Now, that's way off the grid here, right? But what I need is like a good indication of what this looks like. So I know that when x equals 2, right, this is going to go up to 32. So between 1 and 2, it just goes up straight, and it barely touches like that x equals 2 mark. So this is going to go up narrow like this. Okay, and you don't have to put arrows, all right? Okay, so that's what that looks like. So do you see how it's like a very thin parabola? Okay, so what's the domain here? We said before that it's all real numbers. And what about the range? 0 to infinity. X-intercepts 0, 0, or f of 0 equals 0. Y-intercept, same thing. Okay, now end behavior. Left end behavior. As x's go to negative infinity, where does the y value go? Where does f of x go? Positive infinity. And as x approaches positive infinity, where does f of x go? Positive infinity. Okay, is there any place where this is not continuous? No, so it's continuous everywhere from negative infinity to positive infinity. Okay, increasing, decreasing. So where is this increasing? From where to where? 0 to infinity, and then it decreases negative infinity to 0. Okay. Either, I'm just going to stick with brackets. Okay? All right. Next, I have an odd exponent. So in this case, it's an odd function. So when one end will go to positive infinity, 1 to negative. Okay, so 0, 0 here is the center. So for the positive x values, right, if I go over 1, how much do I go up? Negative 1. I go down negative 1. If I go over 2, how much do I go down? Negative 32, right? So again, it's going to be very narrow. Now it's going to be symmetric on this side. So if I go left 1, I'm supposed to go up 1, and then, right? Question? So 1 would it be 5 or would it be? No, it's just 1. Oh, it's always 1. Huh? 32, yeah. So here it'll go down again. It'll be very, very narrow, like this. Okay. Okay, so domain is all reals again. How about range? Right. X-intercept is f of 0 equals 0 again. And so is the y-intercept. As x approaches negative infinity, where does f of x go? Positive infinity. As x approaches positive infinity, f of x goes to negative infinity. This is continuous everywhere. Okay, where is this function increasing? Nowhere, right? So we say none, and it's decreasing from negative infinity to positive infinity, all right? So it's an ever decreasing function. Okay, take a look at this one. Here I have 2x to the negative 2, all right? What we're going to do here, we're going to write this as 2 over x squared. The 2 stays on top because it's got a positive exponent. 2 over x squared. Now, before we think about how the graph of this looks, or, before we think about graphing, I think we can do some of this, right? So let's think about domain. What ideas do you have about domain? Okay, I have all real numbers here. Yeah. X can't equal 0, right? So it's going to be negative infinity to 0, 0 to infinity. Okay? Okay, so that's the domain. So I can put any other value in for x except for 0. Okay, now let's talk about range. Range is my y values. Okay? Okay, so are there any possibilities of my y values being positive? Yes, right? Can I put a value in for x that will give me 0 for y? No. 2 divided by, there is no number that if you divide 2 by, you get 0. Okay? So 0 is not in the range. Can I put numbers in here for x and get negative values for y? No. So the only values now in my range, which are my y values, are positive numbers, not 0, not negatives. So I'm guessing that my range is going to be 0 to positive infinity, but not including the 0. Okay? So do you see how we came up with that? I tried to say, are there any x values that I can put in here that will give me positive values for y? Yes. Can I put in an x value to give me 0? No. Can I put in an x value to give me a negative number? No. Okay? Now, for now, just for this lesson, I'm going to let you look at this on the calculator. Huh? Plug in 0 for x? If you plug in 0 for x, then you get 2 over 0, which is undefined. So there is no y-intercept, and x can't be 0, and y can't be 0. So what is there at x equals 0 and y equals 0? Huh? What kind of asymptote? A vertical and a horizontal asymptote at x equals 0. Okay? And look at that. Look at that. Right? It's exactly what we predicted. Yeah. Which original? 2x to the negative 2? Yes, sir. Because I haven't done any math to it, I've just written it in different form. Okay, so asymptote here. Asymptote here. Don't get too used to putting this in your calculator because, you know, we're going to be doing it by hand later. But now, since we do have the calculator, let's put in some actual values here. I like to trace. And so when I'm in trace mode, I just hit like 1, enter, and it tells me when x is 1, y is 2. And it's symmetric on the other side. And when x is 2, y is a half. Can I have done that in my head? Of course, right? And there you have it. Okay. So, my x-intercepts then, there are none. And there are no y-intercepts either. Now, end behavior. What happens as x approaches negative infinity? What happens to f of x?
Oh, no.
0. As x approaches negative infinity, y values flatten out and near 0. What happens as x approaches positive infinity? 0 again. Where is it continuous? Man, there is definitely a discontinuity here, right? What kind of discontinuity does this have? Infinite one, but where is it continuous? The same as the domain. From negative infinity to 0, 0 to infinity. Okay? Where is it increasing? From negative infinity to 0. And it's decreasing from 0 to infinity. So where is it increasing? We read graphs left to right, right? So here it's increasing until 0, and then after that it starts to decrease. Okay. So let's talk about some radical functions. Radical functions can be written in exponential form, right? So you have x to the power of p over n. And then the same thing can be written in radical form. So, for example, if I have x to the 3 over 2, that can be written as cube root of x squared, right? Now, clearly when we have a radical, we're going to have issues. But when specifically are we going to have issues? For all radical ones or just for half of them? Yeah. When it's an odd, so cube root of x then is a problem? Even. When it's even. So if I have square root of x, I have issues because I can't let the radicand be negative. Fourth root of x, same. Sixth root of x, same. Okay? So again, this is the index, right? If you remember from last year, that's the index. So we have to split this into two when the index is even, when the index is odd. Okay? Now, when the index is even, here's where I have, let's say, square root of x, sixth root of x, right? The radicand must be even, positive. So the graphs will look like this. But when I have, let's say, the cube root of x, is there a value of x that I can't put in there? Can I have the cube root of negative 1? Can I have cube root of 0? Cube root of positive 1? Yeah. My. Yes. It's a cube root. So if I have the cube root of, or negative 8, is there a number, negative number, that I can multiply by itself 3 times and get negative 8? Negative 2. Okay? But I can't do that for like the square root of negative 6, right? Okay. So, that then, right, tells you already that for the cube root of x, the domain is going to be all real numbers. For the square root of x, not. So even indexes, the graph for even indexes will exist only over the region where the radicand is positive. And then for that, it's all reals. Okay, so if we talk about domain and range then, for the even roots, it's 0 to infinity. Now we're just looking at like the parent function, square root of x, not, anything else inside. Yes?
I just have a question for the thing at the top. With the x and like the 3 halves. It says like the n is on the bottom.
Oh, sorry. This is supposed to be the other way around. Okay. So, and then here, I want to call your attention to this. This one here has an absolute minimum at that point. Okay? So this has an absolute minimum. But for the odd function, for the odd root, there is no min or max. Okay? Okay, no absolute min or max. All right, let's take a look at this one. So, all right, before we do anything here, let's take a look at domain, right? What about domain? What can we figure out about domain? Is it all real numbers? 0 to infinity, because I can't put a negative number in here, because then I'll have the root of a negative number. So it's, yeah. So suppose I have negative 1. Cubed is still negative 1. Now I need the square root of negative 2, but that won't work. This is a square root.
Oh, so it's not.
Okay. The range, let's think about the range. Is there any way to get positive y values from this? Is there any way to get 0? Any way to get negative y values from this? No. I see some people shaking their head no. So the range is also 0 to infinity. Can I put in any values for x and get negative 1? Yeah, the square root. Okay, now. Huh? There's no 2. Okay, now. There are two functions mixed in here. This is like ultimate f of g of x. There is square root of x and x cubed mixed into each other. So what happens is, it's like having a split personality. You have one and the other battling one another. The square root of x wants to keep this thing level, right? Increasing ever so slightly. The x cubed is now fighting to increase very, very quickly. So you have a battle between the two. And often when that happens, right, one will win over the other at the infinities, and then the other will win over the other, like, closer to the origin. Okay, so a little background on how functions work. Let's graph this on the calculator because we're still learning. This is going to look like what? Where are your calculators? So it's up to you how to plug this in. I'm going to do 5 times 2x cubed, whoops, to the power of 1/2. Is that the same?
Yeah.
I didn't have to put that 3 in parentheses. It just sort of worked out. So look at what I did, right? Look at what I did. Oh. No. So look at what I did. 5 times the square root of 2x cubed, right? Is that the same as 5 times the square root of 2x cubed?
Yep.
Okay, it's all about becoming sophisticated math students, right? Sometimes it's easier for me to find that button than the nth root button. It's the same. The calculator realizes that it's the same. Okay? When I graph, that's what that looks like. So do you see how it's like a battle between, you know, a square root and an x to the 3. So when I trace this, menu, trace, 1, at 0, we know that. When x is 1, y is 7 already. When x is 2, y is 20. So all I'm going to do is put in here the 0. When x is 1, y is 7.0. And then I know that it's going to go up. Okay? All right, we're going to fill these out very quickly. The x-intercept is 0, 0. Y-intercept is the same. Okay. What happens as, what's the limit as x approaches negative infinity? Well, this thing ends here. It never even goes into the negative infinities. So it's dne. When you say 0, it means as x approaches to a negative infinity, this is flattening out. But it's not. It's stopping right there. There isn't even a graph in that region. So it's dne. Don't get creative and put in like other language there. Yeah.
So when you say negative, that's talking about, it's not talking about it's just decreasing.
No, when x is approaching negative infinity. Yep. So this is continuous from 0 to infinity. It's increasing from 0 to infinity. And it's never decreasing, so none. Nope, not dne. None. Okay, now we're not going to reach for our calculators just yet for this one. What kind of graph is this? It's a cube root, correct? What does cube root look? Parent function looks like that. Okay, now this guy has a few things happening to it though. What is the negative? Therefore, what does it do?
Going down.
Reflection around the x-axis. Good. What does the 3 do? That 3. Ah, it's a vertical shift. We're usually used to seeing it as like blah, blah, blah plus 3. Now I move the 3 over because I can do x plus 3 or negative x plus 3 or 3 minus x. That's the same. So I move that 3 from there to here. So that's a vertical shift up to 3 units. Is there a horizontal shift here? Yes. Where? How did we find that? What did we do? You set that equal to 0. X is moving to the right 1/5. Look at you guys go. Okay, so that center then is not at 0, 0. It's at 1/5 and 3, the most random of places. Right? Huh? So that's the thing. This is not a dilation. That's why I don't dwell too much on the horizontal dilations. It's because, you know, for us, it's very difficult to tell it apart. But this is not a dilation. Yeah, it's just a shift. So, okay, we are going to graph this because I want us to figure out the correct x and y intercept. So if this, okay, I'll go over that later. So much to teach, so little time in the year. Okay, so 3 minus, let's do cube root here. So I'm going to do control that one. Whoa. Okay. Cube root of, what was it? 5x minus 1. That's what it looks like. Wait, you can't see it. You know you can like move this thing up, right? You can if you put the hand, like little hand, in like a white piece of, you know, just like here, and then press and hold. You can move the entire screen. And then here, I'm going to grab this guy and move it up. Okay, so let's figure out x and y intercepts here. Menu, 0. Analyze graph, 0. It's at 5.6. And then menu, if I trace, what's the y-intercept? It's when x is 0, right? So if I, when x is 0, it's 4. Could we have done that by hand? We could have plugged in 0 by hand, but I also want you to see how to do it on the calculator. Okay, so it's at 0 and 4 and then 5.6. Okay. All right, let's do domain and range and stuff here. So domain and range are all reals. So x-intercept, f of 5.6 equals 0. Y-intercept, I'm just going to write it here. We could have done 3 minus cube root of 5 times 0 minus 1. And that gives you 3 minus minus 1, which is 4. So it's at, I'll just write it this way, 0, 4. No, if I haven't specified, no. That's why I'm doing both. So you guys, so your eye is trained for both. Huh? 3 minus minus 1. Okay, end behavior. As x approaches negative infinity, f of x approaches positive infinity and then negative infinity. It's continuous everywhere. You gotta love those cube root functions. Where is it increasing? Never. Where is it decreasing? Everywhere.
These are getting much better.
Yeah,
Mine are.
100%.
I used to draw double circles.
Same. I used to do that in algebra too. But
No,
now I'm
like 2 weeks ago. I was
But now, like, I never can go back to
It's like an infinity motion. And these are called like, they're like, huh?
I could never do it.
It's like a figure eight. It's like an eight
I would always, like,
in figure
forget
skating.
it's infinity and, like, write it eight. And then realize that there was
Okay. Oh, we have 10 minutes. Let's solve. Okay, let's solve some radical functions. So I know you hit on this a little bit last year. The most important thing is you want to isolate the radical expression if you're solving for radical functions, equations. Then raise each side of the equation to the power equal to the index. Solve. And then perhaps the most important is to check for extraneous solutions, right? Okay. These are solutions that come out in the math, but they don't really work in the equation. Okay, what's important for step one is if there are two radicals in the equation, it really helps if you put one on each side. It's fine. You just want one radical on each side, and then you can put the number, you know, with whichever radical you like. Huh? That you won't have to solve. Okay. So this one, first I want to isolate the radicals. So let's add 3 to both sides. Yes, quickly. If there are two radicals, put one on each side. So here I'm going to get 2x plus 3 equal to radical 28x plus 29. Now I square both sides and I get 4x squared plus 12x plus 9 equal to 28x plus 29. I'm going to bring everything to the same side. So when I subtract 28x, it'll be negative 16x. Subtract the 29 minus 20 equals 0. I'm going to factor out the 4. Then I'm going to factor some more. So that's going to be x minus 5, x plus 1. Does the 4 make a difference here? No. So I get x equals 5, x equals negative 1. Now, we need to check. So let's check x equals 5 first. When you check, it has to be in a step right before you squared. You can't put it in the step after you squared because everything will work once you squared it, right? You won't get any extraneous solutions. So either in the very first one, the printed one, or, you know, 2x plus 3 equals the square root right before we squared it. I'm going to put it in the very first one. So let's see. Is 2 times 5 equal to the square root of 28 times 5 plus 29 minus 3? And so is 10 equal to, this will be like the square root of 169 minus 3. So yes, that works. Okay. Now let's check x equals negative 1. Is 2 times negative 1 equal to the square root of 28 times minus 1 plus 29 minus 3? Is negative 2 equal to 1 minus 3? It is. So both of them work. And that's fine. You don't have to like eliminate one of them. It could be that both of them work. The issue is, this is a square root, so it exists over half the domain, right? When you square the equation, you artificially introduce solutions to it that would otherwise not have existed, because you're making the domain all reals by getting rid of the square root. So then you have to see, are the solutions you got in the original domain or are they not? Okay? All right, let's do one more. This one, I subtract 8, so I get 4 equals cube root of x minus 2 squared. Now, if it's a cube root, I need to raise everything to the power of 3. So 64 is equal to x minus 2 squared. Take a square root, take a square root. X minus 2 is plus or minus 8. X equals 2 plus or minus 8. So x is 10 or negative 6. The domain for this was always all reals, so we never had an issue of not working, so we don't need to check. It's a cube root. The domain is all real, so you don't need to check. Okay, take a look at this last one. The last one, I need to square both sides. So I get x plus 1 equals 1 plus 2 times the root times that, so it's 2 root 2x minus 12 plus the square of the root. So now I have, okay, so what I'm going to do is move everything. I have a root again. I need to square again. But first I'm going to move everything to the left side. So I subtract 2x, I get negative x. I subtract all the constants, I get 12, equal to this. Now, you can divide by 2 if it's going to divide evenly everywhere, but it's not going to divide evenly here, so let's not divide it. Let's just square. Okay, x squared minus 24x plus 144 is equal to 4 times, because I square it, 2x minus 12. So distribute x squared minus 24x plus 144 equals 8x minus 48. Bring everything to the same side. We're done with the roots. I get x squared minus 32x plus 192 equal to 0. Okay, and here's the, the thing. You have to factor out like the 192 such that it adds to 32. It's 24 and 8. Yeah. So x equals 24, x equals 8. Now you have to check. So if you check x equals 24, I'm going to put it in, this first one. I get the square root of 25 on one side. Is that equal to the square root of 48 minus 12? It's not. So that one doesn't work. So we throw it away. But this one does work. So we keep it. Yeah, I checked it and it worked. Okay, no. One does, okay.